We're going to check the last problem by factoring. We're going to use two different methods, the ACB method. So here's A. O and C. I didn't write C yet. It's minus 4, right? When I subtract the 5 from both sides, I get 45x squared plus 57x minus 4. So the A is 45, and the C is 4, negative 4. Okay, so just getting rid of that. Maybe I'll get rid of that. We'll see. Great. I guess I won't get rid of that. Maybe I will. There we go. Good. Okay, so 4 times 45. Well, that's 180. And by the way, so that's AC, and it's negative. So factors of 180, that's a lot of factors, that add up to 57, which is B. Okay? So, well, I know I'm going to skip 1 and 180. I'm going to go right to, my first one's going to be 90 and 2. Oh, it's got to be negative 2. I knew my big number was going to be negative. It's going to be positive because this is a positive 57, right? So that would give me 88. No good. Let's see. I'll let the 2 borrow one of the 2's from the 90, and I'll have 45 times negative 4, and that gets me 41, so no good. Let's see. I'll borrow 3. So we'll say, let me think here. That's 15. Is that right? And negative 12. Oh, I went too far because now I only have 3. I need 57. All right. What else can we do? Well, we know that 3 is a factor, so we'll say negative 3 and 30. That's a difference of positive 27. Sorry, positive 27. Let's see. What else can we say? Well, 5. How about 5? 5 is a factor of 90 because it ends at 0. What goes with 5? Well, 18, huh? 18 and 5. And that's 13. Well, that seems unlikely, doesn't it? Seems like I'm not going to get anything to go. Oh, I'm making 90. Hang on. I don't want 90. I want 180. So let's go back here. Sorry. Let's go back. We said 3 and 30, but really we wanted 60. 3 and 60. And that was my positive 57. I missed it because I started thinking about 90. Okay. So I thought, well, that's taking a long time. Maybe it's not going to work. But it does work. And now we rewrite the problem and we say 45x squared. What should go with, I guess I'll put, I don't know, I guess I'll put the 3. We'll say negative 3x and positive 60x, and then negative 4. So just to review, the 45x squared and the minus 4, they stay the same. Okay, you see that? They stay the same. However, the middle term, positive 57, is the same thing as negative 3 and positive 60, right? I just rewrote it in a way that's going to be helpful to me, based on this trick that I have for AC. And then I take out 3x from both these terms, these first two, and I say, how much is left over? I think I'd get 15x is left over, and then minus 1. I took everything out, so there's still a 1. And then for this next one, I'm going to say, I'm taking out a 4, so plus 4, and that leaves behind 15x and minus 1. All right, so now I can see what my factor is going to be. It's going to be 15x minus 1, and it's going to be 3x plus 4. And so I say to myself, well, let's see. I know that I don't want the 15 anymore. For this x right here, I don't want that 15 anymore, so I'm going to put 15 on the bottom. And I do want a 1, so I put 1 on the top. And so x equals that. X equals. If I plug that in for x, I get 1 when I multiply by 15. And 1 take away 1 is 0. And then over here, I'm going to have x is equal to a negative because I need a negative to make that plus 4 become 0. I don't want the 3 anymore. Oops. I don't want the 3 anymore, so I put the 3 on the bottom. And I put the 4 on the top. Okay? So I say, all right, those are my factors. Those are my factors. So we take a look up here, and we say, yes, that's what happened. Negative 4/3 and 1/15. Now we're going to complete the square. And so let's see, we'll say, we can't have that 45 out in front, can we? So we're going to say 45 out in front, away from the x squared now. And we'll say plus 57 over 45. And that's factoring the 45 out. If I distribute that back in, I'll get 57, right? Okay. And then, who built this problem? This is amazing. So to get our perfect square, we're going to multiply that by 1/2. We take half, right? So 57, we'll do this over here. We'll say 57 over 45 times 1/2. That's what we always do. And then we square. Okay? Well, what is that? Well, what's 57 squared? 57 times 1. So 57 squared, that's 3,249. 3,249 over 90 squared. What's 90 squared? Well, 9 times 9 is 81, and 2 zeros. So that's my perfect number. Wow. And let's see, I still have my negative 4. I didn't do anything with that. Still have my negative 4. Remember that? And I need to do something to the other side of this because I just added this. And it wasn't, I didn't really add that. I have 45 times that. Because if you look, there's 45 out in front. So it wasn't that I just added the fraction inside. So the 45 is going to cancel, right? The 45's, when I multiply that by this, how many 45s are in 8100? Well, there's 180, so I'd get 180. So I'll keep that in mind here. What did I really add to both sides? I really added 3,249, and not 8,100 on the bottom, but 180 on the bottom. All right. I know it looks like I added that, but because of this, I have to think about what I really added. I'm glad that they're not all like this. So I think to myself, I know this is a perfect square over here. I know it's 45 times a perfect square. It's going to be x plus something. Well, look in here, and that's going to tell me what it's going to be. I'm glad I know that. 57 over 90. If I square that, that's what I get. And if I get two of them together, it'll mean that I can reduce my denominator by half. So that's squared. Minus 4 equals this over here. All I can say is wow. Then I'm going to add my 4 here to both sides. So I'm going to, that 4, what is that 4 really? Well, it's 4 over 1, and I'm going to have to add 100, I'm going to have to multiply 180 to get a common denominator so I can add it. So let's see what we have. 45 times x plus 57 over 90 squared is equal to 3,249 plus 4 times 180, which is, I think did we recognize this from before? 3969 over 180. Yeah, I think we do. And then we're going to divide by 45. It's kind of a weird thing to look at. But I'm dividing by 1. I think it would have been easier if I wrote that on the other side. So I have x plus 57 over 90 squared is equal to 3969. And I'm putting my 45 back, which means I'm going back to what I started with, which is that. So let's see. Let me put that. There we are. And now we take the square root of both sides, right? Square root of both sides. Ooh. Well, both sides are perfect squares, so what may seem like just a terrible thing, and I would never complete the square like this, but if I did, I would get x plus 57 over 90, and I would get, I know it's 63, I've seen it 2 or 3 times now, and I know that I multiplied 90 times 90 to get that. Okay, all right, there we go. It does work, it's just not fun. I'm subtracting 57 out of 90 from both sides. Oh, wait, this is plus or minus, right? Plus or minus when I take, so it's plus or minus. Don't forget that, I did. So let's see here. We'll say x is equal to, I ought to write that negative 57 first, huh? Negative 57 over 90 plus or minus, I was going to say the square root, but it's gone, 63 over 90. Okay, so I know what happens when I add. I get 6 over 90. That seems pretty familiar at this point. And negative 63, that's going to be negative 120 over 90. And I think you can see from before that somewhere, was it up here? Where did this happen? There, it happened up here with our quadratic. Same thing happens down here. So we're going to the same place, and that's good news. We just wanted to confirm it, okay? So at this point, I think that's good enough. That's enough suffering. And we've confirmed, yes, it's true. Yes, it's true. No matter how you do it, this is the graph that we get. And we're happy about that.